Hey guys, welcome to math class today. So unfortunately, Winston, the whiteboard, couldn't make it today. So his brother, William, the online whiteboard, has volunteered to take his place. So this is William with me now, and William actually has eyes. So isn't that nice? All right, so let's go back and think about area. What is area? How we find it. So like we say every single day in our math movie, area is the area inside the shape, right? It's the space that gets taken up inside the shape. Now we've learned two ways to find area. The first way works for any shape. And that is if it is split up into squares like this. You can count the squares to figure out its area. So for this one, the area would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squared units. The second way we talked about only works for rectangles and squares, and it works for squares because they are rectangles, right? Of course, and this second one is when you multiply the length, which is the long side, times the width. Okay, so let's test this out on this one. Okay, so we're going to multiply the length 4 times the width 3. 4 times 3 is 12. We already figured out there was 12. Let's do this one because this one isn't broken into squares. The length is 3. The width is 2. 3 times 2 is 6. Let's check our answers. Look at that! So this area is 12 units squared, and this area is 6 units squared. Now, one thing I want to talk about when we're doing with area is what we do for our units. And lots of you have already been doing this, and we've talked about it briefly, but I want to go in more detail. Is every time you write the area of something and you write the answer, you need to have whatever your units is. That means whatever it is, whether it's centimeters, inches, feet, or if we don't know and just say units, you need to put a squared on top of this. And what this little 2 up here says, say it's squared, and it means how many squares could fit inside. Okay, so this one, 12 squares could fit inside, so it's 12 units squared. This one, 6 squares could fit inside, so it's 6 units squared. So that's what that means. That's what we'll be doing. Now, why do we bother with area? What could we use it in real life? Well, a lot of people recently have been doing a lot of sewing, making masks and all kinds of stuff. And so when you use sewing, you need to figure out how much of a certain type of fabric you need. You need to figure out the area of the fabric you need. You also, when you're working with wood, let's say you're making a porch or a deck or a table or anything, you also are going to need to know how much wood you need, what area of wood you need. There's lots of other times when you might need area in real life, sometimes even in origami. Now, we've learned that we can count the squares or do length times width, but as I said, remember, the length times width trick only works with rectangles, not triangles, not ovals, not pentagrams, only rectangles. As you get older, you're going to learn other tricks for other different types of shapes. But right now, length times width only works for rectangles. Remember that. All right, so I have 2 rectangles here that we've already gone through. The first one has 12 square units as the area, and the second one has 3 square units. Oh, this one's different, I'm sorry. This next one has 1, 2, 3 square units as its area. Now, what would happen if instead of my shape having 2 rectangles like I have here, what if instead of 2 rectangles, it was one shape like this? Well, it's not a rectangle, so I can't take its length times its width because it really doesn't have a length or width. It's not a rectangle. How do you think I could find the area? Well, duh, the first one is that we could count all the squares. Let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Its area is 15 units squared. Now, there's a faster way to do this that does not involve counting, because when I count, I'll have to lose count, and then I could put 14 instead of 15. Oh my goodness. So the faster and easier way to do is to add the 2 rectangles together. So if I have this rectangle right here and this rectangle right here, and they're together and they're not overlapping. Overlapping means like that, where they're covering each other up, but they're right next to each other, putting in one shape. I can find the area by adding these two together. Let's see if that works, shall we? Okay, so right here I have 12 units plus 3 units. What is 12 units squared, plus 3 units squared? What is 12 plus 3? That's right, it is 15 units squared. So I can know by counting and by adding together these two that it's the same. And this is how, besides counting, this is how I know it works. I'm taking this area, this rectangle, and adding it to this area rectangle. So I know that's how it gets its area. Well, let's try one without boxes, shall we? All right. So this is a shape without boxes in it. In fact, I can even move this line, show you what it looks like. It looks like an L, like that, because it's made up of two rectangles together. And I see that first, I need to find the area of each rectangle. Now, at this point, it's your choice, whatever one you like first. We're going to find length times the width, length times the width. All right, so what's 5 times 3? 15. So this area would be 15 units squared. What's 4 times 2? 8. So this one would be 8 units squared. So now that we know the area, what do we do? Do we add, subtract, multiply, or divide? Okay, so let me think through this. Am I separating anything into equal groups? Well, I'm kind of separating, but really I'm taking two rectangles and I'm putting them together. So it's not division. Multiplying. Do I have lots of things in the same equal amount of groups? No, definitely not. Okay. Subtraction. Do I have something and have something taken away, or am I comparing anything? No. So the only thing that's left is addition, and that's what I'm doing. I'm adding this rectangle to this rectangle to get the area of them together. All right, so I already have it written down here. I have this rectangle is 15 units squared, and this one is 8 units squared. So I'm going to add those together. 15 units squared plus 8 units squared is 23 units squared. That's the area of this whole shape. I didn't have to count any boxes, and I knew this. So the first thing you're going to do is if you see a shape like this and you need to find this area, the first thing you're going to do is to pick one rectangle and find its area. Multiply the length times the width. Second thing is to do the same thing to the other rectangle. Third thing, add them together. Okay? Now let's get harder. Oh, so now I have a shape and it tells me the area of all 3 of the rectangles. But how do I find the area of the whole shape? Help me out, guys. Okay, so I'm going to start off and I'm going to take 10 minus 11 because I think I need to subtract because I'm taking things apart. So 10 minus 11, that doesn't make sense. So maybe 11 minus 10 is 1, 1 minus 3, that doesn't make sense. What did I do wrong? That's right, I'm supposed to add them together because I'm adding rectangles together. I need to add these numbers together. So I need to take 10 plus 11 plus 3. So the whole area of this is 10 units squared plus 11 units squared plus 3 units squared equals 24 units squared. So again, the first thing is I need to find the area of each rectangle. Then I need to add them all together, no matter how many. Now your work, I'm not going to give you one that are 3 or more, just 2. But 3 or more is just as easy. You just have 3 to add. All right, let's try this one. Try to solve it by yourself. What is the area of this whole weird looking shape altogether? Solve it by yourself. Pause the video and solve it by yourself. All right, what's the first thing you did? You found the area of each shape, right? Yeah, they actually already gave it to you, so we don't have to do the first step. What's our second step? We're going to add them together. So 5 units squared plus 9 units squared is 14 units squared is the area of this whole thingamajigger. It's 15 units squared. Now, let's go back to this problem and let's say, all right, so let's say the problem looked like this. Okay, so Mary is cutting some fabric and it looks like this. She needs 12 squared units of fabric to make her project. What is the area of her fabric? is A. And does she have enough for a project? So if you're solving a problem like this, the first thing you're going to look for is solve A. What is the area of her fabric? Okay, so the first thing I need to do is figure out the area of this rectangle and the area of this rectangle. Okay, so I already know that this one is 5 square units and this one's 9 square units. I'm going to add it together. The answer is 14 square units is how much fabric she has. So when it says what's the area of her fabric, the answer for A is 14 square units. Now, a lot of you guys are going to do this type of problem and forget the B. Do not forget the B. The B is important. And this is why. It says, does she have enough for her project? Well, if she needs 12 for her project and she has 14, does she have enough for her project? Well, yeah, because she has 14 and 14 is more than 12. Now, if this were instead 3, or let's have this be 2 units squared, and she only had 11 units squared of fabric, would she have enough? No, because she needs 12. So when you're looking through this problem, it's pretty simple. For part B, when it says, does she have enough for her project? Does he have enough for a project? Think about how much do they have and how much they need. Sometimes it'll show you how much they need and you have to figure out if they have enough. So be thinking through that. So today we were reminded that there's 2 different ways to find the area of a rectangle. You can count the boxes or multiply length times width. When you write your answer, you're going to write it with whether it be centimeters, feet, inches, whatever, with a squared on the top because you're telling me how many squares fit inside that shape. We've learned that length times width does not work with other shapes that are not rectangles, but that if you have a shape made from more than one rectangle put together, you can find the separate rectangles and add their areas together to find the area. So for example, with this shape, we found the area of this rectangle plus the area of this rectangle, and that gave us the answer. For this shape, we found the area of this rectangle plus this one, and that gave us the answer. For this one, we took it a step further to do it in real life, and that we not only found the area of the shape, but we also figured out, does she have enough to make a project? And if she has more than what she needs, then she's good. But if she has less, then she's not. All right, so in your problem set today for number 31 and 32, I was unable to get this on the slide. So this is what I want you to do for problem 31. Go ahead and pause the video. You can go ahead and start problem 31 and then come back and do the rest of the ones later, or you can go ahead and do the rest of your problems and then come back to 31 when you are finished. Either way is okay. I just had to, unfortunately, put 31 in the video. So pause the video and solve this problem. All right, and the same thing for 32. This is problem 32. Pause the video and solve this problem. All right, you guys got this. Have fun and have a great day.